The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to take a look at the second part of section 4.4. And so I'll go ahead and get right into that. We have some more application problems. So again, this is 4.4 part 2. Okay. The first problem says financial planning. In investing $6,000 of a couple's money, a financial planner puts some of it into a savings account, paying 6% annual simple interest. The rest was invested in a riskier mini mall development plan, paying 12% annual simple interest. The combined interest earned for the first year was $540. How much money was invested at each rate? So we've got the savings account and the mini mall. Now, there's a couple of different ways we can set this up, and I'm going to use this. So this is going to be the savings account, and this is going to be the, the mini mall. All right. And I'm going to let X be the amount invested in the savings account and Y be the amount invested in the mini mall. It says in investing $6,000 of a couple's money, a financial planner put some of it in the savings account and the rest in a mini mall. So we have this scenario. Okay, X plus Y equals 6,000. So X, the amount invested in the savings account, Y, the amount invested in the mini mall, the total investment, $6,000. Okay, now it said, let's see here, savings account paying 6% annual interest, and the rest in the mini mall paying 12% annual interest. The combined interest earned for the first year was $540. So $540 interest. Well, it said that was invested for 1 year. So the interest for the savings account using I equals PRT, P would be, the principal would be X, R, the rate would be 6%, and T would be the time. So the interest for the first one would be this. The interest for the second one would be that, and the total interest would be that. Any questions about where I got that second equation? Okay. So we've got our two equations. What I'm going to do, I'm going to do a couple of things. I'm going to take the bottom equation and clear out the decimals. And I'm going to do that by multiplying both sides of the equation by 100. That gives me 6x plus 12y equals 54,000. Okay, so I'm going to use that to replace that original equation with decimals. Then I'm going to take the top equation and I'm going to solve it for one of the variables. Either one is fine. I think I'll solve it for x. So I'm going to subtract y from both sides. So x equals 6,000 minus y. So now, let's see, I'll label these 1 and 2. I'm going to substitute this in the place of x in the other original equation. So that's going to give me 6 times the quantity, 6,000 minus y, plus 12y equals 54,000. Distributing the 6, I get 36,000 minus 6y plus 12y equals 54,000. Combining like terms, I get 6y plus 36,000 equals 54,000. Let's see. I'm going to write that over here. I'm going to subtract 36,000 from both sides of the equation, and I get 6y equals 18,000. Divide both sides by 6, y equals 3,000. Plugging that into this top equation, I get x plus 3,000 equals 6,000. Solving for x by subtracting 3,000 from both sides, I get x equals 3,000. Checking it in this second equation, 6 times x plus 12 times y equals 54,000. This is what, 18,000 plus 36,000, 54,000 equals 54,000. It checks. So in this case, let's see, the original question said, how much money was invested at each rate? It would be, let's see, I'm trying to find a place to write it here. Let's see, $3,000 at 6% and $3,000 at 12%. Now, it doesn't always work out that it's the same amount invested at each rate, but in this case, each rate, yeah. But in this case, it worked out that way. All right. Any questions about this problem before we go on? Okay. Let's take a look at another problem. Let's see here. It says the jet stream. The jet stream is a strong wind current that flows across the United States. Flying with the jet stream, a plane flew 3,000 miles in 5 hours. Against the same wind, the trip took 6 hours. Find the speed of the plane in still air and the speed of the wind current. All right. So how about if we let speed of plane equal x and speed of wind current equals y. Okay. Let's see here. Okay, so let's see where to go. The jet stream is a strong wind current that flows across the United States. Flying with the jet stream, so with jet stream, the plane flew 3,000 miles in 5 hours. So the distance, 3,000 miles, time 5 hours. Okay. Against the same wind, so against the jet stream, they refer to it as the jet stream and then the same wind. Let's see. The trip took 6 hours. So it's the same distance because it's the same trip. And it took 6 hours. Okay. So all that's left to fill in is the rate. Well, we've said that the speed of the plane, and that's the plane in still air without any resistance pushing it or hurting it, is x. Okay. But going with the jet stream, the speed of the wind, sort of, you'd call it a tailwind, is helping to push it along. So we would add the wind speed. Okay. Going against the jet stream or against the wind, we'd have the speed of the plane minus the jet stream. Any question about how I got that situation? All right. So our two equations are, this equals 5 times x plus y. I'm going to put the 5 in front. And the second equation, 3,000 equals 6 times x minus y. Again, any questions about that?
Nope.
Right. Now, the thing that I see here looking at this problem is this part right there. If I could add those two pieces together, wouldn't I get 2x and the y's would cancel? So I'm thinking I want to use the elimination or the addition method. And in fact, to make life easier, here's what I'm going to do. I'm going to take the top equation and I'm going to divide both sides by 5. That's going to give me 600 equals x plus y. I'm going to take the bottom equation and divide both sides by 6. That's going to give me 500 equals x minus y. Now, the reason I did that is because I saw that by dividing the top equation by 5 and the bottom equation by 6, I could get rid of all those extra coefficients. Okay. Mm-hmm. And then adding these together, I'd get 1100 equals 2x. Divide both sides by 2, x equals 550. How nice is that? Well, let's see. X equals 550. If x is 550, putting it up there, we'd have 600 equals 550 plus y. Subtracting 550 from both sides, y equals 50. Let's check it in this equation right here. 500 equals x minus y. Let's see, x is 550 minus y, which is 50. 500 equals 500. It checks. So here are my two answers, but the question said, find the speed of the plane in still air and the speed of the wind. Speed of the plane in still air is 550 miles per hour. The speed of the wind is 50 miles per hour. Okay. Any questions about that problem? All right. We're going to look at another one of those. A student requested it. This is actually problem number 6 from 4.4 part 2. Very similar problem. It says use two equations and two variables to solve the problem. A boat can travel 96 miles downstream in 4 hours and can make the return trip in 6 hours. Find the speed of the boat in still water. All right. So the boat is going upstream and downstream. So we've got the boat in still water. We'll call that x. And the speed of current we'll call y. Okay. And let's see here. Distance equals rate times time. And we've got downstream. So downstream. And then the return trip would be upstream. Okay. It says a boat can travel 96 miles downstream in 4 hours. So 96 miles, time is 4 hours, and can make the return trip, which would also be 96 miles, in 6 hours. Find the speed of the boat in still water. In other words, without any current. Well, going downstream, you've got the speed of the boat in still water plus the speed of the current pushing it along. Going upstream, you've got the speed of the boat in still water minus the current, which is running against it. Are you okay with how I set that up? Okay, we'll assume that's a yes. So now my two equations are 96 equals 4 times x plus y. 96 equals 6 times x minus y. Once again, I'm going to divide the top equation by 4 and the bottom equation by 6. let's see, 96 divided by 4. 96 divided by 4 is 24 equals x plus y. And then 96 divided by 6 is 16 equals x minus y. Again, this works out very nicely because 4 divides evenly into 4 and 96, and 6 also divides evenly into 6 and 96. Adding these together, I get what? 40 equals 2x. So x equals 20. Plugging that in there, 24 equals 20 plus y. Subtracting 20 from both sides, y equals 4, and then 16 equals 20 minus 4, checking it in the other. So it checks. So the boat in still water is 20 miles per hour. The speed of the current would be what? 4 miles per hour. The actual question just asked for the speed of the boat. So this is the answer that you would put into the box. Questions on that problem? All righty, let's take a look at another one. Let's see here. This says mouthwash. A pharmacist has a mouthwash solution that is 6% ethanol alcohol. Isn't that what they put in gasoline? Ugh. And another that is 18% ethanol alcohol or ethanol. How many milliliters of each should be mixed to make a 750 milliliters of a mouthwash that is 10% ethanol alcohol? Okay, so this is a mixture problem. And again, I like to set these up using what I call the box method. Okay, now let's see. A pharmacist has a mouthwash solution that is 6% ethanol alcohol and another that is 18% ethanol alcohol. So we're going to call this one the 6% and this one the 18%. How many milliliters of each should be mixed to make 750 milliliters? So if we call the 6% solution X, the 18% solution Y, we get X plus Y equals 750 milliliters. That's our first equation. The mixture, it's how much, so that's X of the 6% plus how much of the Y is 18% to make 750 milliliters of the mouthwash, that is 10%. Okay, so our second equation becomes 0.06x plus 0.18 y equals 0.10 times 750. Any questions about that? All right. I'm going to multiply both sides of the equation, of this second equation, by 100. So I get 6x plus 18y equals 100 times 0.10 would be 10, and 10 times 750 would be 7,500. Okay, so now I'm going to use these two equations. I'm going to take the top one and solve it. We solved the last one for x. Let's solve this one for y. So I'll subtract x from both sides. Y equals 750 minus x. All of that's going to go in the place of y down here. 6x plus 18 times 750 minus x equals 7,500. Okay. 6x plus, let's see. 18 times 750 is 13,500, and then minus 18x equals 7,500. Combining like terms, I get negative 12x plus 13,500 equals 7,500. Subtract 13,500 from both sides. Negative 12x equals, let's see here, negative 6,000. Divide both sides by negative 12. And let's see, if we take that divided by that, we get x is 500. Okay. Plugging that up here, if x is 500, 500 plus y equals 750. Subtract 500 from both sides, y equals 250. Check it here. 500 plus 250 is 750. Oh, down here, excuse me. Let's see. 6 times 500 would be 3,000. So we've got 3,000 plus 18 times 250. Let's see, that would be 4,500. And those add up to 7,500. Okay, I just did that last part in my head there, plugging it in here. 6 times 500 is 3,000. 18 times 250 is 4,500. Those add up to 7,500. It's trying to get it all on the same page. Okay, now the original question was, how many milliliters of each should be mixed? So X is 500 milliliters. So that's the 6%. And Y is 250 milliliters. That's the 18%. And there we have it. All right. Any questions about any of this?
Nope.
Anything else you'd like to look at?
I can think of.
Okay, well, that's all I've got for today. So we've got some mixture problems involving solutions. We've got financial problems involving money, and distance, rate, time problems involving a current working against or for a plane or a boat or whatever the object is. All righty,
Okay.
well, that's all I have for today. So I will be back at 1:15 with an office hour. Should you have any questions? Otherwise, we'll start.